Hey everyone, welcome back to the channel and I hope you are all doing well. So today we are going to discuss about this Kubernetes services and this is the particular service that is the load balancer, okay? So first you need to understand the problem behind it, why we need it and why NodePort is not sufficient. So first of all, the very basic thing, if you have to go on any particular website like these, Netflix.com, Flipkart and Amazon and all, you will just type these domain names. You will not type the IP address and the port along with that. And also, basically, this is possible when your node is publicly available, but in production clusters and everywhere, we keep our nodes always in a private subnets. Okay, so that's why this is not recommended, and also we may need to track so many nodes, and if any node goes down then you will need to make that node up. All these drama is there. Okay, so NodePort we basically use it just for the internal use cases if anything is there. So now let's just move on to the today's topic, that is the load balancer service. So it's just a service which basically we use it to expose our application to the internet. Okay, so what happens basically in this, whenever you create a service, it's just like a normal service. We will see further how we create. So you just give the type as the load balancer, and what happens basically, like if you're using any cloud, like you are using either AWS or Azure or GCP. So in cloud environments, if you give these type as a load balancer, so all these clouds will create their load balancers. Like whatever, like in AWS we have ALB and NLB. In Azure also something is there, and GCP also. I'm not actually able to recall the name, but these all cloud providers also create their own load balancers. Okay, and this is the flow. Basically user will hit the load balancer and load balancer will redirect to the service to the pods then. Okay, so now let's just see how you can create it basically. So it's simple, you just give the type as the load balancer, that will do just now. And yeah, the port and the target port we have to give, that's it. And if we are using currently Minikube, and also for that, obviously we will not be having a load balancer, right? So there is a one hack, we can use Minikube tunnel over here, and with that you will get one external IP. So let's just quickly do it, so that will be the hands-on for this class. Let me just open up my, just a second. Yeah, so here we have one service. Okay, so I'll just delete this particular service. I can just show you this get svc over here. Just delete this particular, delete service.yaml, and I'll just open this service.yaml and edit in this only. I don't need NodePort now. Instead of type, I'm just going to give the load balancer, and this is spec, and this selector we have given app my nginx, because I am running basically pods with that level. So here you can see my fe, my dep is basically being used. It is having that level. Okay, so it will redirect to these pods. So now let me just quickly do this, apply hyphen f service.yaml. So if I just do now get svc, so for now it will show me this external IP is pending. But if I just open up a new terminal and just do this Minikube tunnel, tunnel, okay, it will just ask you to enter your password. You can just enter, and once here it will show you. Okay, now it's there, like you can see services nginx svc and all, load balance simulator. So it's just like a simulation. If you do get svc, now you got the external IP, right? So you can just open up your browser, you can just do the curl request like this http, and by default port 80, so you can see the default page of your nginx, right? So in this way, you just create a load balancer. So, but when you do in a AWS and all environments, so you basically get a load balancer IP. So that I'm going to surely show you in the next class, maybe, because that is an important thing if you are aware of it. So now let's just move forward with the flow. Okay, and also let me show you here if I just to get SVC and all. Okay, here I'm getting this load balancer external IP, and here also you can see the port, that is the basically the node port. So what happens internally whenever you create a type of load balancer, then also your node port service gets created internally, and that is used. Okay, so if I just show you the flow, you will just understand how it's happening. So here basically you can see the whenever a user request, okay, so it will go to the, for example, it will load balancer, then it will be like created automatically underneath the LB service. You can see the node port, and then cluster IP service it goes, and then your particular ports whatever you have. So this is the flow actually, and this is the most asked interview question you can face in your interviews. Like, does Urban's replace NodePort, or how is the flow they can ask, and there they expect you should be aware for after the traffic reaches to the NodePort. So now let's quickly see the difference between these two. So NodePort is basically good for testing, obviously, and accessible by Node IP and port, mainly for local testing and manual error-prone access, and not ideal for production, obviously. So load balancer basically we get a public IP or DNS name, and it automatically distributes traffic, integrates with cloud providers, and a standard for production, obviously. So now we have a real world example. Let's say we are having a myshop.com, some e-commerce website, and DNS points to the AWS load balancer, which spreads the traffic. Okay, here you can see load balancer is here. We are having multiple nodes attached to this as a target group. And if any of the pod goes down or something happens, the traffic goes to the healthy pods. So this is also one thing. Okay, so now for you the task is just create a NodePort service first, and then you change it into a load balancer. You can check the external IP field, what is happening. Then you can use that Minikube tunnel, and yeah, you can access it. And even you can just scale up your pods, so that even if you scale any number of pods, so still your traffic will reach out to your pods. Okay, and here also you can see the challenge task is that run kubectl describe SVC whatever service you created, and then you need to understand about the types, what is the selector, what is the endpoints, port mappings, and all everything you need to see, and you can just comment out your findings. Okay, so yeah, that's it guys for this particular video, and I hope you liked it. So if you have any question, you can just ask me in the comment section, share this particular video to your friends, and yeah, that's it, and see you in the next one guys. Thank you so much for watching.